Good afternoon, everyone. Welcome to this first webinar of a series of two regarding the European Ground Motion Service data interpretation and usage. I am Lorenzo Solari, and I work with my colleague Joanna Balasis Levinsen in the implementation of the European Ground Motion Service. And we work for the European Environment Agency, which implements the Copernicus Land Monitoring Service, of which the EGMS is part. Today we are here for this first webinar, and the second one will be on the 17th of June, 2024. The first one is, let's say, more technical, dedicated to the data download and usage of the data within your GIS, whereas the second webinar will be more about data interpretation. This is the agenda of today. Right now I'm doing, let's say, the welcome and the introduction part, and then we will have a live demo, which is going to be done by my colleague Gianmarco about the use of the EGMS data in your project, and then we will have more or less, let's say, 15 minutes to have the Q&A. Some housekeeping rules. This webinar is being recorded. We will upload the recording on our CLMS page, the same one where, for example, you registered for these webinars. Please follow the general webinar courtesy rules and stay with your microphone muted. And if you would like, let's say, to speak instead of posting a question, we can give you the floor if needed. Also, regarding the questions, you can scan the QR code that you see in this page, or you can follow up the link that Sophia put in the chat to access Slido. Slido is an app that you can use to basically give to us your feedback, but also to reply some questions that we will post during the webinar that we can use also for the Q&A part. So let's move to the technical part, and let's speak about the European Ground Motion Service. I hope that some of you or all of you already know the product, but here it is a brief overview of it. The EGMS, it's a continental scale high density map of ground motion. What you see in the map is 13 billions of points that have been produced by analyzing hundreds of Sentinel-1 radar images. And each measurement point has a value of ground motion velocity and a time series. So you can follow both, let's say, the value within a time period of ground motion, but you can also follow its development over the time. So you can follow how the behavior of the ground motion is in the last 5 years. And we cover geographically the Copernicus participating countries. What does the EGMS measure? It measures the millimetre-scale motion over time of ground reflecting features. So something like bare rocks, buildings, everything that is mainly an anthropogenic structure will be a measurement point. What is not going to be a measurement point is, for example, something that is covered by water, something that is covered by high vegetation, or something that is within a crop area that changes too much between the acquisition of the satellite. What we can measure a multiple number of elements, but I would say that the classic targets of the EGMS and of satellite interferometry in general, which is the technique behind, is land subsidence. As you can see some example here from Spain or Greece. You can follow up landslide slow phenomena in general. You can follow up also the movement of some large-scale infrastructure, or in the case, for example, of Iceland, you can track the motion connected to volcanic eruption or earthquakes. The EGMS needs to be interpreted. That's why we also organized this series of webinars, because one of the difficulties of the EGMS is that we provide this shiny map with a lot of points with many different colors, but of course we don't provide the key for interpreting those points. Because we have many things to answer ourselves. It's first of all what's happening in our deformation map, why the deformation map shows some blue points, some red point, and why, for example, in this slope we have one side of the valley that is blue and one side of the valley that is orange. And you, let's say, should trust me when I tell you that there are two landslide facing opposite direction of the slope. But I think that after these two webinars, you will be able to read these maps as well by yourself. Regarding the portfolio, I will, let's say, run this quite briefly, but we have a lot of material that you can find on our website to help you understand in the portfolio. I will show you where to find such documentation. But first of all, we have three products that are named as basic, calibrated, and ortho. You will find them named also as level 2A, level 2B, and level 3. The basic product is what we call the classic deformation map. So it's a map of velocity of ground motion and time series that is computed along the line of sight of the satellite. What is this line of sight? It's essentially the line that ideally connects the satellite with the ground pixel. And this map is computed with respect to a local reference point. This means that for every processing unit, you have to think about a rectangle of 100 by, let's say, 150 by 80 kilometers, more or less. You will have an estimation of this velocity with respect to this local reference point. This means that the estimation will be relative. And this also means that each processing unit is, let's say, independent with the neighboring one in terms of estimation. To overcome this, we defined what is called calibrated product. We basically take these 50,000 processing tiles over Europe and we attach them, let's say, to a velocity model derived from global navigation satellite system data. This means that we do a sort of rectification of the data with respect to their reference point. But this means that we will be able to compute not only the local components, but also the large-scale component that is carried on with the GNSS. This means that we will have a model, we will have an estimation that is not anymore local, but that is, let's say, European-wide. And so this makes the product absolute. Finally, we have the ortho product, which is a sort of combination of the data that we derive for the calibrated product, because for the calibrated product, we derive the data for both the ascending and descending orbit, because the satellite flies from the north to the south and to the south from the north. And according to some, let's say, geometrical tricks that we apply to the data, we are able to sample the data that are originally derived on the full resolution of the satellite to this new grid of 100 meters. And for each grid, we compute the components of motion. So we can estimate the vertical, or also you can visualize it as the up and down component. And also we can compute the horizontal component, the so-called east-west motion. Finally, as I mentioned, we have plenty of information for you to investigate, to read, if you are interested in knowing more about the technique or the background of the product. You can reach this documentation on our website, and you will find there some applications and use cases, so some users that reported how the EGMS is used, some outreach material. I will explain a bit to you this later, and also the documentation, and as well, of course, our viewer that Gianmarco will show you. As said, we also have some outreach material, and here you have the full list of the 5 webinars that we did last year to, let's say, explain how the EGMS can be used to perform some investigations in some thematic areas. That's it for my introduction part. I know that's a lot of knowledge to be digested, but I think with, let's say, these webinars and the following one, you will understand a bit more about the product. So I give the floor to Gianmarco, who is a senior technical leader working with INSAR at Nazca. Nazca is an Italian remote sensing company, which is part of a large consortium that produce the EGMS, which is led by EGEOS. Gianmarco, the floor is yours. I will stop sharing my screen now.
Thank you, Lorenzo. And I will go to share my screen with my presentation. Just a moment.
If you allow me, whilst you set up everything, just to remind you that we are posting on Slido some questions for the audience. Right now, we've changed our question and we are asking which GIS software you use for analysis. So feel free to give us your feedback. And again, remember that you can post your questions on Slido for the Q&A session. Gianmarco, the floor is yours.
Thank you, Sophia. I think you can see my screen and the presentation mode, I hope. Okay, let's go to explain the EGMS data. The EGMS data are distributed as CSV file or T file. For this product, only for the ortho product, which every of these contains several measurement points, where more specifically the file size could be overpassed about 500 megabytes. Indeed, the file dimension depends on the number of the measurement point scenario and the other factor. For example, a CSV file of a barren area will have a less number of measurement points than a urban sector, because the former is characterized by a high density of artificial reflectors such as building, railway, highway, etc. The download EGMS file can be opened easily by a GIS software, as QGIS, also, you can open EGMS data with any operative system, so Mac OS, Linux, Windows, and so on. And about 100 or 200 giga of free disk space are suggested. Clearly depends on how many layers you want download. Okay, let's navigate to EGMS portal and access by a European login. So I change the screen, the sharing screen. Just a moment, please. Okay, so ready to access to EGMS portal by clicking this button, sign in with European login. So going to login phase, okay. No. Mm. Okay. Okay, now we can able to explore the EGMS portal. Okay, the principal toolbar you can use there are the main tools to navigate, to help you navigation in visual inspection of measurement points, download tool, etc. The first button, help and info, by clicking this tool, all the information about the navigation tool are shown, such as the navigation using touch, maps layer and search results, and so on. To modify the legend, we need to show legend button by the legend manager layer appear, and you can modify the transparency of your PS layer or ortho layer. You can change the pixel size of your dots, or you can set the minimum and maximum value of your legend for fine, very fine or quartz, or if you need to apply a custom legend, you can put every number that you want, right? And in okay, and then you can change the color, the palette color of your PS legend. For example, white, black, and black, red, or insert default. So, sorry. Okay. By if you need to takes you the show your location in map, you can click this button takes to use the function. The geolocalization tracking has to be enabled on your personal computer, so you can click to enable, and here you are, and show the position where you are to analyze the PS data. Okay, let's move on another location example. Okay, move on, for example, in Aosta Valley. Okay. Okay, if you want to the 3D function, clicking this button is possible to activate the 3D visualization, and using the left button of the mouse, we can modify our point of view. For example, in this area, in Alpine area, we can show the distribution of the ground deformation, modifying our point of view. In this case, we can appreciate the deformation of this landslide affected by this mountain in northern Italy. If we clicking a point where the time series of these points appear, For this layer, we is activate the ortho layer, more specifically the vertical component. The red dot define the downward movement, and the blue dot define a upward movement. If we want change to view another layer, we can close the vertical layer by the layer manager and clicking, for example, the basic layer, the ascending, for example. Okay, we need to take a while to click. Okay, we can analyze the time series. As if we click the view data, we can show the attribute table of this point. One moment, please. Okay, it is possible to view the track of the Sentinel-1 satellite, the interferometry, the acquisition mode, the birth of the image, the latitude, the longitude, and of the point, root mean square error, temporal coherence, and so on. Data define the displacement of every image, analyzed image. Okay, if we, for example, but if we can clicking by compute average, is it possible to analyze the mean time series of displacement for a cluster point? We try to analyze, for example, okay, we can show it is possible to analyze, yes, the mean time series of displacement for the the number of selected points, and if we click the view data, the values will be the average. Every field is average of the number of selected points. Okay. If we want to share what we are analyzing, we can generate a link to the current view using the this function. We can control click and copy link address to share, for example, via email or more easily via WhatsApp. Okay. Okay, we go to another area to, sorry. Okay. Okay, as Lorenzo mentioned, there are 3 levels of EGMS products in this region of Northern Europe, more specific the Finno-Scandinavia region. We can appreciate the difference of these 3 level products. For the basic level, there are the ascending orbital geometry exhibits stable values of mean velocities. Nonetheless, the calibrate level has the post-Glasson rebound phenomena. Indeed, if we enable the ascending calibrated level, we can appreciate all the dots approaching move towards the sensor. This thanks to the GNSS calibration model. So from to a relative level of a relative velocity, thanks to GNSS model, the going to absolute velocity. If the ortho level is the vectorial decomposition, combining the the two orbital geometry, ascending and descending. It is possible to analyze the deformation along the vertical component, so up and down, and east horizontal components, so eastward and westward deformation. The pixel size or the ground deform resolution of this dot is 100 meters. Additionally, we can load a WMS layer directly into the portal. For example, we can upload the WMS link of the imperviousness density. This product captures the percentage of change of soil sealing. If to upload this WMS layer, we can go to this WMS server tool, copy and paste the WMS, add WMS. In the layer manager appear the added WMS layer. If we click to enable the WMS, we can analyzing, combining the information retrieved from the imperviousness with the analyzed ground deformation. Okay. But if we want to download EGMS data on an area of interest, we need to navigate to the selected area by or searching by toponym or by UTM coordinates. In other hands, you can copy and paste coordinate from Google Maps or Google Earth. So we can, for example, go to, I don't know, Tromsø in Norwegian fjords. Okay. Here we are. Okay. Formats we need to select. Firstly, we must select the sector that we want to download using the this function, geographic archive search. So clicking this function and we can create a polygon that we want to download, for example, this one. Okay, and appear in this case all the available products. But if you go to the product archive, we can select for example, the level or the baseline that we want download. If we want to download the 2015-2021 baseline or both, we can select both the baseline. Or if we want to select to download only the basic level, we can select, for example, the both baseline of the basic level of EGMS data. And if by clicking archive, we can show all the available data. This yellow polygon define the size of every download, the footprint on every layer. Okay, we want to select, for example, we want to download, for example, the ascending product and descending product. So we select this, all the layer, going to the archive and create a download link. The sharing screen. Okay. Okay. So the archive, the EGMS archive links is a list of all links to download links for every layer, that selected layer, and to download each of every layer, you need to copy and paste this link in a browser and launch the download. For example, we can launch the first link. So I copy the this link and going to in the browser. Turn in the browser. 1 second. Okay. So I like. One moment. Download. Oh, okay. Sorry. I think there's some problem with the download link, but in general, if you it is possible to launch the download process by clicking copy and paste in a browser the link of every link in the downloads txt. Okay. Therefore, I have chosen 3 different case studies in Europe to show the EGMS data. The first one is, Tromsø in some landslides affected in Norwegian fjord in Tromsø. Just a moment, please. Okay. Okay. So we can search the landslide by coordinates. So retrieving from Google Maps. Okay. Just a moment, please. Okay. So in this area, it is possible to analyze several huge landslides in Norwegian fjords. More specifically, we can, with the enable the 3D visualization, we analyzing in 3D dimension the deformation process. And also we can select the cluster of landslide to analyze the mean time series of displacement. This is possible. Here is the time series. I am calculated from average of 19 points of this landslide from the vertical component of European vertical component of ortho level. So we can analyze the horizontal component. Okay. We can change the view. Okay. It is possible to find that these landslides move westward with a high velocity, and this landslide or time series of his west component of 1 point with mean velocity of minus 11 millimeter per year. Okay. In this sector, we we can go in another sector. For example, I choose the ground deformation over the volcanic edifice. For this case, I choose the Vesuvius, the most important volcano in Italy. So we can go to in the crater sector of Vesuvius. Oops. Please, and we can open the ascending calibrated geometry. In this area, we can, it is possible to highlight the ground deformation, the high ground deformation affected the crater of the Vesuvius edifice. More specific, the ascending geometry is shown show negative movement of the ground. If it is possible to compare this calibrated product with the basic product. In this way enable the calibrated ascending geometry, and it is possible, and it is possible to define this sector is affected by a subsidence caused by the volcanic process effect in the southern Italy. Other this, we can use the EGMS data not only for analyze the geodynamic process, but we can apply EGMS data for analyze, for example, man-made edifices, such as attaining them in Poland. So we can go to in Poland, in the selected dam in Poland. Just a moment. Okay. Okay. As you can see, this tailing dam is affected by a high rate of deformation. The tailing dam is constructed with an upstream method where the new embankments are founded on tailing. The vertical components show downward movement of the embankments, and more specific, if we enable the east-west component, we can appreciate just a moment and modify the size, the pixel size of the measurement point. It's impossible to define that half part of them is characterized by westward movement, the red dots of the layer, and the half part is characterized by eastward movement with a high rate of velocity. But also we can go to analyzing, for example, the post-seismic deformation and co-seismic deformation. In this case, I choose the Larissa, the earthquake of Larissa in 2021 in Greece. It is possible we can go to in the Larissa sector. Okay. Okay. It is very interesting to show the co-seismic, post-seismic process and co-seismic process. Indeed, if we clicking show a time series of every a time series, it is possible to define the gap of along the formation caused by the earthquake event in 2021. So the east-west vectorial decomposition and the deformed displacement after the event of the ground is about 60 millimeter. Okay, if we change the vectorial decomposition and we show the vertical component, and this we can it is possible to show that after the earthquake the ground is was interested by a huge deformation process that's with a cumulative displacement of about 2000 millimeter. It's very interesting that show us the EGMS data could be used to analyze co-seismic process and post-seismic process. Okay, for each of them, I will I create a QGIS project to show, for example, the difference between, for this case, the 2015-2021 baseline bit and 2018 and 2022 data. So I need just a moment. I change the screen to show you the QGIS project. Okay. Okay. I think you can show you can view my screen now. The EGMS data to upload, for example, the download layer in QGIS, you need to use the function add layer, add CSV layer, and the software sets automatically the latitude and the longitude field when you select the path of your CSV EGMS data. By a GIS software, is it possible to combine more source, more geodatabase to analyze EGMS data. In this case, I upload the European Fault Source Model 2020, and it is possible to analyze the subduction zones and the active fault in Europe. If we go to Larissa earthquake, okay, move on this. Okay, it is possible to this is very interesting because the main the Larissa is interested by a set active fault, and the active layer is the descending basic layer of the 2018-2022 baseline. So we can compare the deformation, the ground deformation of this product with respect to the first baseline, so the 2050 and 2021. It is possible that as in after the main shock of the Larissa earthquake, there is a huge the deformation process is not interested by a high rate velocity, but after the main shock of Larissa earthquake, it is possible to appreciate the high deformation caused by the seismic events. And now we can go to another layer, another area. We can go to, for example, in going to detailing them in Poland to analyze in GIS the deformation process of tailing them. So combining thanks to EGMS function, we can analyze more specifically the deformation process of structure of the man-made structure, and we can, in this case, I activate the east-west deformation component of ortho level and combining with the up-down vectorial component of ortho level, more specific, the last update of GMS data, so the 2018-2022 baseline. So I think it's all. If you want to, I conclude my the presentation.
Good, thank you so much, Gianmarco. I hope everyone found it interesting and inspiring. We have received a number of questions, and we will try to go through as many as possible here. If we can't make it through all of them, and regardless, then we will upload responses to all the questions on the event page, so you'll be able to find it soon, anyway, online. So there was a first question from Vandana, and please excuse me if I mispronounce some names. We are coming from all over the world here. And she asked how to locate a certain point by directly inputting the coordinates. And hopefully you got your answer already, as Gianmarco showed that already a few times. But to respond quickly, you can simply copy paste the coordinates from Google Maps, put them in, there you go. Then there was a potentially related question from Dragos Infoplaskis saying, hey, what about WMS services? And now I'm not so sure exactly what the question is. Gianmarco also presented that it's possible to upload VMS layers to the Explorer. And then maybe you can say something about the evolution of the service.
Yes, sure. Right now we are in the process of tendering a new 4 years, let's say, extension of the EGMS, bringing it to 2027. And as part of the new COFO tender, we made a clear requirement to have an API, first of all, for reaching the data and downloading the data. And also, we will investigate the possibility to having a WMS of at least maybe the ortho product, because as you can understand, it's also a time series product. So the generation of the WMS is not so straightforward, but expect something, let's say, from 2025.
Yeah, and then that also responded, I hope, to Marco's questions about whether there was a way to stream the points as a WFS or WMS. Then there was a question from Marius about this big data gap in the middle of Europe representing Switzerland, and whether there's any plans for filling that out. This is not going to happen right now, but I believe Switzerland is discussing whether to join Copernicus, and if they do, we will also map Switzerland, and that regards other countries joining as a Copernicus participating state. Then there is a question from Laborda. Do you plan to add more points? to fill in missing places or as requested by, for example, research institutions. As I said, there is this plan depending on who are Copernicus participating countries. Otherwise, we do harmonized processing here, so we know we have data gaps here and there, and that can be introduced for different technical reasons, but we don't plan to receive requests, for instance, to add this and that area, because we want to do this pan-European harmonized mapping. And so some areas will maybe not have observations right now, maybe in the future in case, for instance, infrastructure is built, and we will just have to wait and see. Then there was another question by Marco. He asked whether there's a way to select the data directly by country to download, such as by a predefined country boundary polygon.
I can take this. It's again part of the evolution of the service. We learned, let's say, a lot in both the way the data are made available and also in the way they are accessible. So we will have some tools by 2025 to download data on area of interest, and not by country, but let's say on area of interest for sure.
And then Yuki asked, because he's heard that several companies such as EGEO and TRL Temiro process data for the EGMS. Are there any ways to confirm who have processed which data?
I can reply to this. There is no, let's say, trace of this directly in the attribute table of the data, but actually when you download the data, you have also the XML file that is linked to the data, and there you will have a number that points out to the company. This is also described in the product specification document that you find online on our website.
Then Alexandra posed a question, namely how to obtain a finer resolution for the product.
Yeah. Let's say that right now we generate it on 100 meter because the EA has its own grid for, let's say, generating some sort of what are called very high resolution product, and these can fit in with those. So we have a suite of product as it was imperviousness that are generated on top of this 100 meters grid, and so we decided to go for it for the ortho as well, as we consider it, let's say, the last product in the line, so the real level 3 product there. But potentially you can either, there are many papers that were written about the, let's say, the resampling of PS points into, let's say, the components. So it is doable to be done, let's say, by users, or you can wait, let's say, 1 year or something, and another, let's say, piece of the evolution will be to actually to provide to users some notebooks, and one of these Jupyter notebooks can be to obtain for yourself the ortho product. It can be directly from the calibrated, or if you want it from the basic product.
Thanks. Then Christo is asking, what is the procedure to obtain up, down, and east-west movements? Can it be done by programming?
Yes, can be done. Let's say that there are some reference paper there. It's nothing else, let's say, nothing else in brackets than trigonometry. So once we know let's say, the acquisition geometry of the ascending and descending orbit, and we are aware of the geometry of slope of the terrain, there are basically some rules that can help us extracting the two components. Anyway, on our website, again, you will find the ATVD, so the algorithm theoretical basis document, in which you will see both the explanation of the figure I had in my presentation, let's say in words, but also by the point of view of the formulas that were used to derive the ortho product.
I can also add, building on this evolution that has been mentioned by Lorenzo before, and that we're now preparing the continuation of the production. Part of the tasks there will focus very much on user uptake, as we have now, but also specifically in publishing scripts like Jupyter notebooks to support the users in actually using the products, and not just talking about how they can be used for A and B applications. So perhaps we will publish something that will exactly help making this ortho product from some level 2 products to foster the actual usage. Then there was another question from Marco on how the seasonality is defined.
Yes, I can take this. This is, let's say, a more technical question. You have consider as a reference again the product specification document, but there you will find the mathematical, let's say, the formulation of the seasonality in practice. Basically, we evaluate the residual of the model, and then on base of those we estimate the amount of seasonal variation along the time series. And together with the seasonality, when you open the data, you also have an estimate of the standard deviation of such seasonal amplitude. And maybe in the meantime, I can also add something that is not directly related to this. When Gianmarco was showing the color bar, remember that there is also an option for you to assess the colorblind color bar, let's say. And also regarding the problem for the download, you have to remember that once you generate a token for downloading the data, that token will have, let's say, a lifetime of 1 hour. After 1 hour, if you don't immediately download the data, you will have to generate another token right away. This is to avoid, let's say, over pushing too much our server, because as you can understand, it's a quite large volume of data.
Then there was a question from Miguel about whether the horizontal component includes the north-south direction. And the short answer is no, because the satellite is flying pretty much north-south, and it's only taking pictures looking to the right. So we simply cannot right now see the deformation in the north-south direction. In the future, with new missions, there's a plan that we will be able to obtain this in combination with, I think, the Harmony mission?
Yes, potentially, yeah.
But it's down the line. It's coming because we know it's a component that we need to learn and to know. But right now, when we have these satellites flying north-south and they are right-looking instruments, we simply have no means for reliably estimating this component.
I think we speak of at least 2029 or 2030. So.
If things go according to the plan.
Exactly.
So, down the line. Okay, we have just 2 minutes left, so maybe Timothy's question will be the last.
Yes.
And he is asking whether we can add an option to download the CSV files only containing the mean velocity data to simplify the download and processing.
Yes.
Very good question.
Oh, yeah, very good question. Let's say that as Copernicus service, we provide the whole, of course, data set. There are ways of scripting it that we also, you will find on our website, let's say, some guidelines that give you already those scripts to, let's say, reducing the amount of data you can download. There is a series of some simple script that can be used and then to extract the data into QGIS. Also, there are some tools that are being developed by, let's say, research centers. We have one of those hosted on our GitHub, the EA GitHub, which is basically a standalone software that you can use to download the data, resample them both spatially or on the base of the kind of parameter that you would like in the data set. I will add the link to our GitHub in the, let's say, the minutes of the webinar.
Yeah, so more questions are coming in, but unfortunately we're running out of time. So keep in mind that we will answer these questions and upload the answers to the event page very soon. So otherwise, I think we should just say thank you for joining, and to the speakers. And we hope that we will see you again on June 17th for the next webinar.
Yes.
Thank you so much.
Thank you.
Have a good day.
Bye-bye.
Thank you, everyone.
Thank you.